Hello, grade 7s. In today's lesson, we're going to look at calculating the mean of a data set. And our learning outcome for the lesson is to demonstrate an understanding of central tendency by determining the mean. In a data set, the mean is the sum of a set of values divided by the number of values in the data set. A sum means you take all your values and you just add them together. We can write this down with a mathematical equation that looks like your mean of a data set is equal to the sum of all the numbers. And again, the sum is the addition of all the numbers divided by lowercase n. In this equation, the lowercase n represents the number of values that you have in the data set. There's a different word that's used for calculating the mean that's probably used a bit more commonly. When we calculate the mean of a data set, what we're doing is we're just calculating the average value in the data set. And unlike calculating median and mode, to calculate the mean, we don't need to actually write the data in ascending order. Since we're just finding the sum of a bunch of numbers, the order of addition doesn't make a difference. Like, for example, it doesn't matter whether you go 3 plus 4 or 4 plus 3, they still equal 7. So because of this fact, we don't need to write in ascending order. We'll still calculate the sum correctly, whether the data is organized or not. All right, so example, I want to calculate the mean of the following data sets. And then if the mean is not a whole number, then I want to round it to the nearest tenth of a decimal place. A. The data in A is actually the scores I had on a 9-hole round of Frisbee or disc golf. So got 6, 4, 6, 6, 4, 4, 6, 4, 6. Okay, so first thing I want to do is I want to calculate the sum of those numbers. So the sum of those numbers, let's pull up the pen here. Your sum would be equal to, just add them all together. So you have 6 plus 4 plus 6 plus 6 plus 4 plus 4 plus 6 plus 4 plus 6. So you have 6, 4, 6, 6, 4, 4, 6, 4, 6. And if I believe if I add these numbers up correctly, I do get a sum that is equal to 46. So 46 total throws over 9 holes of Frisbee golf. Much better than what my normal golf scores would be. My normal golf scores would be like 12, 13, 15, 20. Maybe a 6 in there if I'm lucky. Okay, let's identify the number of values in the data set. So in this data set, it was 9 holes I played. I have 9 values, so therefore n would be equal to 9. To calculate the mean, let's write down that formula for equation. So we have mean is equal to the sum of the numbers in the data set divided by n, which is the number of values in the data set. And that's how we define mean. So that would be equal to 46 divided by 9. Again, a fraction means division. Now, if I plug this into my calculator, I'm going to get a repeating decimal number. So I would get 5.1111, etc., 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 etc. Now, we want to round to the nearest tenth of a decimal place. To round to the nearest tenth of a decimal place, you need to look at, so the nearest tenth of a decimal place is this one. You need to look at what the digit is following the tenths position. If the digit following that tenths position is 5 through 9, we're going to round the tenths digit up. If it's 0 through 4, we're just going to keep it as the same digit. So in this case, the digit that follows a tenths position falls into the 0 through 4 category. Therefore, we don't round. We're just going to keep it as 5.1. Therefore, my answer would be a mean is equal to 5.1. So on average, I was doing about 5 throws per hole. Okay, second one. I have some temperature values. I just chose temperature values in Calgary over the course of a week, although I added the decimal places just to show an example where I'm using decimals. Okay, so first things first, calculate the sum. So my sum is, I'm just going to add all these numbers together. So that'd be 6.7 degrees Celsius plus 13.8 degrees Celsius plus 17.4 degrees Celsius plus 17.9 degrees Celsius plus 13.1 degrees Celsius plus 12.5 degrees Celsius plus 12.3 degrees Celsius. If you're dealing with a physical quantity that has units, you should write the unit beside all the numerical values. Okay, so let's just double check we got the numbers correct. 6.7, 13.8, 17.4, 17.9, 13.1, 12.5, and 12.3. When I add those numbers together, I get a sum that is 93.7 degrees Celsius. Now let's go to the equation for calculating the mean or the average. So your mean would then be equal to the sum of all your values divided by n, which is the number of values in the data set. And the number of values in this data set, if you count them, it was temperature values over the course of a week, therefore you have 7 values. Okay, so that would be equal to 93.7 degrees divided by 7. And when I calculate this, I get a number with a lot of decimal places, but I don't know if there's an actual repeating pattern to it. I'll just write down a few of the decimals. It depends on what kind of calculator you have in terms of how many digits are going to be displayed on the screen. Okay, so you have 13.3857 degrees Celsius. So I'll just do it for 4 decimal places. In terms of the rounding, so again, I want to round to the nearest tenth. And to do that, you have to look at the digit that follows the tenth position. If the digit that follows the tenth position is 5 through 9, we're going to round the tenth digit up by 1. Therefore, the mean would be equal to, okay, the 8's going to round the 3 up to a 4, so you'd have 13.4 degrees Celsius. And that's it. You can practice this by completing page 431, numbers 3 through 6 in your MathLink 7 textbook. And then next time we'll talk about range and outliers. Until then.